Hi viewers, welcome back. You are watching Electrical Concept channel and we are continuing our video number 5 for a series of videos related to the electrical substation construction concepts. So now today's our topic is understanding substation interlocking through interactive SLD simulation. As we have discussed in detail about the high voltage GIS substation, their SLDs, their detailed equipment, and we have shared the drawings and pictures of those components to give you a certain level of details within a shorter period of time. So it is always a good idea to work on a practical systems instead of theoretical things. So I have tried to explain and search for an interactive single line diagram to show you how the operations take place. I have developed a single line diagram of a single feeder, which is the typically used in nowadays modern substations to explain to you the concepts of the operation and the interlocking. So this video is going to be super interesting. I believe you will enjoy it and you will share it with your friends to and subscribe for the best results. Okay, now let us move to the main topic of this operation interlocking, that what is interlocking. Okay, interlocking is actually a method to protect the system from any damage due to human mistakes or any other reason, unauthorized access. In real life, we are using many interlocks to have a safety in our life. Like one example, I can give you the recent from my car. It is an automatic car, and you cannot start it until you fulfill the prerequisites for that. How the starting switching of the car, the prerequisite is that its gear, its transmission gear should be placed at the point P parking. Then only you can switch on the car. If it is on some other places like D or reverse, sorry, car will not allow you to start. It will give you the message. Why this interlocking in the car? Because once you will start, it should not automatically start moving. So once it is in the parking, so it will give you a safe start for that. So all the interlockings are implemented like in electronics, digital electronics, with the and or gates. And or gates, everybody knows. And means the two inputs, for example, should be on to give the one output. Alternatively, or is any one of the input can trigger the output. For disconnect, for the circuit breaker to operate, for example, the disconnector Q1 and disconnector Q9 should be closed. So this both can be the dry contacts of these disconnector are connected in the series through wires. So it will give you a AND logic. While or any one of them can be closed. So these interlocking are done in a substation through the actual contacts, not through the auxiliary contacts of the relay, because these auxiliary relays are depending on the DC supply or AC supply. So once the DC supply will fail, this interlock will be fail. So it is always must to do the interlocking through an independent contacts, actual mechanical contacts, which are not dependent on any supply. So dears, now I have explained to you the concept of the interlock. You can remember it in a substation specifically. An interlock ensures that certain electrical devices such as circuit breakers, switches or transformers can only be operated in a safe and coordinated manner. Interlocks can be of mechanical type, electrical type and software interlocks. In modern substation we have wired interlocks, they are called hardware interlock, and we have a software interlocks through the SAS system. So both are done in a redundant way, so we should have a double confirmation before the operations. Now let us move to our next slide, to which will further open how these interlocks are implemented. Now this is a single line diagram of one bay which we discussed before. Here you can see some devices are there. I hope you remember from my previous video. The main devices are circuit breaker, disconnector, earthing switch, CT and VT. Can anybody tell that what are the operable devices? The devices which can change their position. open and close. They can be opened and closed. What are those devices? Yes, these are circuit breaker, disconnector and earthing switches only. What about CT and VT? These are always connected in most of the cases. These are not operated regularly during the normal operations. They are always connected. So the only operable devices we are considering here are circuit breaker, disconnector and earthing switches. Further, these circuit breakers, the circuit breaker is shown here, disconnector switch is shown here, and other disconnector is shown here. Q1, Q2, Q0 circuit breaker and Q9 is a isolator, line isolator. So I am sure you people are familiar with the truth table from the digital electronics. So here also any AV interlock has a truth table. Every substation has a philosophy of interlocking approved by the client and implemented by the contractor through the design principles. So the AV equipment will have a certain conditions for its opening and closing. For example, I will only explain here one condition: closing of the circuit breaker. Closing of the circuit breaker, for that the prerequisites are that the circuit breaker Q0, which is here, must be open, Q1 must be closed, and Q2 must be open, not grounded, and Q9 must be closed, and Q8 must be open. If you meet this condition and you will give command to the circuit breaker, it will be easily closed. The second example of closing the disconnector switch. The disconnector switch, as you know, is an offload device. It cannot be closed while the circuit breaker is on or the circuit is energized. So the prerequisites for the Q1, which is shown here, Q1, we have to close it. So we have to check the circuit breaker is open in open condition. 0 means open. Q1 itself should be in open because we have to close it. Q2 should also be open because only one can be closed, and other conditions are not applicable for the Q1. If you meet this 1, 2, 3 conditions and you will give a command to Q1, it will be closed easily, otherwise it will give you the error messages. So this is done automatically. You have to not take care for that, okay, let me check circuit breaker is open or not. If you meet this condition, it will allow you to close or do the operations. So this table is showing the closing operations, and this table is showing you the opening operations. Let us do one example, then we will do practically in the next slide that how we are going to apply this in the real example. I will explain to you here the one example of opening of the circuit breaker, which is actually here shown. We have this condition here. So from here we have to open this breaker. To open this breaker, you first the interlock will check first that Q0 should be in close, which is here closed. Q1 should be closed, so which is here, and Q2 should be open, it is here, and Q9 should be closed, it is here, and Q8 should be in 0. Okay, 0 means it is not connected with the earth switch, but here it is connected, so it will not allow us to do this. To meet this requirement, you have to fulfill this prerequisites, then you will give a command to the circuit breaker, then it will be open. Same is the case with the others. You can try it with this application. I will give it to you depending upon your requirement, but these all conditions you can try by yourself in the application. It's very interesting. And now let us move to the simulation, and we will do one by one all the conditions. We will do the wrong operations, we will do the right operations. So this is an interactive SLD. After this slide we will switch on to the application.